Hello, welcome once again to ASOM online math class. In this class, we are going to discuss the laws of indices because this is a very important topic in mathematics that comes out every now and then in Neco, Waec, and the Nabteb examination. And in this class also, we shall explore questions that have come out from your Neco, Nabteb, and even Waec examination to help you prepare for your forthcoming Neco and Nabteb examination. So, but before we delve into problem solving, let us briefly refresh our minds on the laws of indices. Just like on the Mount Sinai, the Moses was given the Ten Commandments, and whoever that disobeys these commandments may not make heaven. Also, indices has its own commandments, and if you fail to abide by these commandments or these laws of indices, you will go to the hellfire of indices, in the sense that you are not going to do well in indices. So to combat with problems in indices, you have to first of all master these laws of indices. A good mastery of these laws will help you to do well when it comes to indices. All right, now these are the laws of indices. We will have the first one called the multiplication law, which is telling us that whenever we are multiplying, provided that the bases are the same thing, look at the base here. This is called the base, and these are the powers. All right. Remember, indices are just the plural of the word index. Okay. So indices are the plural of the word index. So index is the singular, and index means raised to power, the power. That's just the meaning of index. Okay, now, so when you have y power of a multiplying y power of b, provided that the bases are the same thing, you have to just add the powers. So this will give us y power of a plus b. Just add the powers, provided that the bases are the same thing. Okay, look at this is y and this is y. You simply add their powers together. Also, the same thing applies to division. When you find out that the bases are the same thing also, you've got the right to subtract the powers. Okay, so once you see division, you are subtracting, but if it is multiplication, you are just adding. So here I'm just going to call it y power of a minus b. The third one, where we have x power of 0, any number raised to the power of 0 implies 1, apart from 0. Because 0 is not inclusive, 0 power of 0 is not 1. So apart from 0, any number raised to power of 0 will give us 1. Even though there is an argument here, some persons will tell you that 0 power of 0 is still 1, but that is not what we are here to discuss today. Okay, so and you can prove this by saying when you have something like 3 power of 3 divided by 3 power of 3. Of course, this can be written as 3 power of 3 over 3 power of 3, which is the same thing as 3 times 3 times 3, because this implies that 3 is into 3 times, over 3 power of 3 again is 3 times 3 times 3. Now, this divide itself is 1, divide here you have 1, and 1 over 1 will give us a 1. Also, in the same hand, from the second law of indices here, when you have 3 power of 3 divided by 3 power of 3, since the bases are the same thing, you are free to subtract their powers. 3 power of 3 minus 3, I'm subtracting their powers, which is 3 power of 0. And if this gave me 0, automatically 3 power of 0 will also be 1. If this value here gave me 1, 3 power of 0, which is still the same thing, is equivalent to 1. That is to tell you that any number power 0 is the same thing as 1. Okay, so this is 1 here. Now, when you have a negative index, x power of negative a, this can be written as 1 over x power of a. Assuming you have, let's say, 2 power of negative 3, this can be written as 1 over 2 power of 3. This is a negative index, so this is how you simplify it. Now, whenever you have two powers like this, one inside the other outside a bracket, what you have to do is just to say a times b, and a times b will give us ab. Okay, so this is the same thing as ab. When you have something like 2 power of 3 bracket 2, for instance, which is similar to this particular law here, you can call it 2 power of 3 times 2. From this law, what I did here, I said a times b, so I'm free to say 3 times 2, and 3 times 2 here will give me just 2 power of 6. So you've just seen how to deal with this. Also, whenever you have a fractional power and the numerator and the numerator is 1, so this is the same thing as a root x, just a root x here. That's what you're going to do, nothing else. But whenever both the numerator and denominator are not 1, just the denominator here, which is a, you write first root x, then everything power of the numerator b, everything power of b, like this. That's just the difference. So these are the laws of indices, and a good mastery of this law will help you to do well when it comes to problems in indices. So let us take some problems coming from Neco and the Nabteb examination to help us concretize our learning of indices. Okay, so the first question we have to solve today is coming from Neco 2011, number 8 questions. Neco 2011 number 8, and we have 27 to the power of negative 1 over 3 times 64 negative 1 over 2 times 4 power of half. A good look at this question will make you to know that all of them are not in the same basis, and therefore you cannot just apply the laws of indices straight by adding the powers, because this is multiplication. So you have to blend it a bit to make it conformable for the application of the laws of indices. Now, because I have here, this is what I have, 27 to the power of negative 3 times 64 to the power of negative half times 4 to the power of half. Seeing these 3 here, I should know that I'm going to look for a number I'll raise to the power of 3 to give me 27. And this number is 3. The 27 here can be replaced with 3 power of 3, because 3 times 3 times 3 will give me 27. So I'm replacing 27 with 3 power of 3. Then I have my negative 1 over 3 times, according to the laws of indices, there is a negative law that tells you that when you see a negative power here, you are free to still call it 1 over 64 power of half times any number power of half implies square root of that number. So this is just square root of 4. Then this will cancel out. We are having 3 power of minus 1 times 1 over 64 is power of half here, so I will say square root of 64 times the square root of 4 will just give me 2. So 3 power of minus 1 means 1 over 3 times, this is now 1 over 8, because square root of 64 is 8, then times 2. These 2 can be called 2 over 1. This here is 1, this here is 4. So the answer is just 1 times 1, which is 1, over 3 times 4, which is 12. If you don't like what I did here at this step, I can still redo it using another method. So here, I call this 27 3 power of 3. Then I have minus 1 over 3 times 64. Because I'm seeing 2, I'm free to call this 64 8 power of 2, because 8 power of 2 can still give me 64. Then I will have my negative half times 4 also can be called 2 power of 2, because I'm seeing 2 here. So I will still write my power of half. Now this 3 will cancel 3. I'm left with 3 power of minus 1 times 2 will cancel 2. I'm left with 8 power of minus 1 times these 2 will cancel 2. I'm left with 2 power of 1, which is just 2. 3 power of minus 1 means 1 over 3 from the laws of indices, times this means 1 over 8 times this is just 2 over 1. Then 2 here is 1, 2 here is 4. When we multiply numerator, we have 1 over 3 times 4 is 12. So you can see, no matter how I take it, I'm arriving at the same answer. Remember, this is Neco 2001. So let's take another question. All right, the second question I have here says 125 to the power of negative 1 over 3 times 64 to the power of negative 1 over 3 times 81 power of 0. This is coming from Neco GCE, that is November, December 2002, number 42. So we have to simplify this. So I'll have to rewrite it again. We have 125 to the power of negative 1 over 3 times 64 to the power of negative 1 over 3 times 81 to the power of 0. Now, because I'm seeing 3 here, I'll ask myself, what number power of 3 will give me 125? If you think over it very well, you see that 5 times 5 times 5. When I multiply 5 by itself into 3 times, I'm going to get 125. Therefore, I'll use 5 power 3 to replace 125. Then I'll write my minus 1 over 3 times, what number power of 3 will give me 64? Of course, it is 4, because 4 power of 3 will give me 64, times any number power of 0 is just 1 from the laws of indices. So now this 3 will kill this 3, this 3 will kill this 3. We are left with 5 power minus 1 times here is 4 power minus 1. Of course, 1 is nothing. Then 5 power of minus 1 means 1 over 5 times 4 power of minus 1 means 1 over 4. And 1 times 1 is 1 over 5 times 4 will give us 20. So the answer to this particular question is just 1 over 20. Let's take another one. Okay, the third question for today says x power of 4 equals 0.25 to the power of 2. This is coming from Nabteb 2004 question Nabteb. This is number 8 question also. And we are asked to find the value of x here. This can be written as, so let's rewrite the question. X power 4 is 0.25 power of 2. To be on a safer side here, let us convert this 0.25 to a fraction. It will become 25 over 100, then to the power of 2, because 0.25, when I draw a straight line under it, seeing point 1, number 0, number 0, so it's equivalent to 25 over 100. Now here, 25 here is 1, 25 here will give me 4. So I'll see that x power of 4 is equal to 1 over 4 to the power of 2. Now, these two here, this 1 over 4 can be written as x power 4 equals 4 power minus 1. That's the meaning of 1 over 4 to the power of 2. Also, if I'm to go further, I have to call this x power of 4 equals 4 can be seen as 2 power of 2 minus 1 times 2 will give me minus 2 here. Minus 1 is times in 2 because 4 alone is 2 power 2. Then this can be seen as x power of 4 equals 2 power of minus 4. Okay, now 4 divide 4, we have 1 here. So x is just 2 power of minus 1. That is what is giving us, because there is still a negative sign here. And 2 power of minus 1 is just 1 over 2. So the value of x here is just 1 over 2. That's just the answer. Okay, so let's take another one. Okay, so the fourth question here is coming from Neco 2002. And it says we should solve for x when we have 9 times 3 power of 1 plus x equals 27 power of minus x. Now, this is just the initial equation, and for you to deal with something like this, you must ensure that they appear in the same basis. For instance, seeing this 9 can be seen as 3 power of 2 times 3 power of 1 plus x equals 27 can be seen as 3 power of 3, then bracket this minus x that is here. 27 is 3 power 3, 9 is 3 power 2. Now, remember, this is multiplication, and according to the multiplication law of indices, provided that their bases are the same thing, you are free to add their powers. So I can call this 3 power of 2 plus 1 plus x. I'm just adding the powers, equals 3 power of minus 3x, because 3 times minus x is minus 3x. Now, this 3 will cancel this 3. I'll have 2 plus 1 is just 3 plus x equals minus 3x. I kill the bases to have the powers. 2 plus 1 is 3x, then minus 3x. Correct like terms, I shall have that 3 equals minus 3x minus x, because when this plus x crosses over, it turns to minus. So 3 will give us minus 3x minus x is minus 4x. Hence, to get the value of x, I'll divide both sides by 4. I'll have over 4 here, dividing here by minus 4, not even 4, because the coefficient of x is minus 4. This cancels out. So therefore, x is just 3 over minus 4, or minus 3 over 4. You can place the negative sign in either of the numbers. So it's just minus 3 over 4. And that is the value of x here. Let us continue. So the question we have at hand, the fifth question, is coming from Neco 2001, and this is a theory question, question number 3A, where we are asked to solve for the value of x. Just like the fourth question we just concluded now, to deal with problems like this, you have to ensure that they all appear in the same base. So seeing 9 can be written as 3 power of 2, and we'll have 2x minus 1 as the power, times, this is 3 power of 3 plus 1, equals 27 can be seen as 3 power of 3. Then we attach our x. So we open the bracket using the 2 to multiply everything we have in here. So this can be seen as 3 power of 2 times this will give us 4x minus 2, because these are multiplying out. So the 2 is not just times in 2x, it's also times in this one here. Or to be sure of what you are doing, you can enclose it with a bracket. Then times 3 power of 3 plus 1 is just 4, equals 3 power of 3x. Now, because there is a multiplication sign here, you must embrace the law of indices, which is telling us that whenever we are multiplying, we just add the powers. So this is just 3 power of 4x minus 2, then plus this 4 equals 3 power of 3x. You can kill 3 because it's common at both sides. So we have here 4x minus 2 plus 4 will give me just 2 equals 3x. Collect like term, this will come here and this plus 2 will move over. We have 4x minus 3x equals negative 2. When plus crosses over, it becomes minus. Now 4x minus 3x will just give me x equals minus 2. So the value of x here is minus 2. Let us take one more question and conclude. So in the last question for today's video, we want to take one question from Waec, where we'll have 3 power of 1 minus n over 3 power of minus 2n equals 1 over 3. Now, this is a division sign. Forget about the way it's written. So it's not a must. You can see it this way. Because it's division, you simply subtract the powers. So this can be written as 3 power of 1 minus n. This is the power for the numerator. Minus the power for the denominator is just minus 2n. Look at what I'm doing. This is minusing this. The power of the numerator is 1 minus n. Then subtract it from the power of the denominator, which is minus 2n, equals, this can be written as 1 over 3 power of 2, because 3 power of 2 will give me 9. Now simplifying this, I'll have 3 power of 1 minus n. Minus minus will turn to plus 2n equals, from the laws of indices, this can be written as 3 power of minus 2. Okay, because it is a reciprocal 1 over 8. Now this 3 will cancel this 3. We shall have 1 is here, minus n plus 2n will just give me n equals minus 2. Now this one will cross over to the other side, it becomes minus. So therefore n equals minus 2 minus 1. And minus 2 minus 1 will just give us minus 3. So the value of n here is just minus 3. If you've enjoyed what you've watched, kindly subscribe to my channel by hitting the red button. This will only give you notification whenever I upload a new video. Thank you for your audience.